So here begins part 2 from block 8, as we emphasize how do we solve once we know how to complete the square. In this example, we have x squared plus 6x minus 16 equals 0. This is one way of many to do it. We're just going to be consistent with the book in going through these methods. They want to isolate the x terms, so they add 16 to both sides. It looks like this. And this step in purple, which I'll now underline in orange, is the key step to completing the square. Notice they add 9 to both sides. And where did this 9 come from? That comes from 6 over 2 squared, okay, 3 squared, which is 9. That's the idea we showed with algebra tiles. That's the idea we went over in those 3 previous problems. Notice it has to happen on both sides, because if you just added it on one side, like so, that would have changed your original equation. You'd be solving a totally different quadratic. By adding it to both sides, the equality is maintained. This is the same equation as this one. Once you've completed the square by adding in b over 2 squared, right, in this case it's 9, you can factor the left-hand side. It becomes x plus 3 squared. Notice this term right here, the factor, it's b over 2. B over 2. And then we square root both sides. Square root of 25 is 5. Because we're doing this square and square root nonsense, there's 2 answers. Minus 3. So positive 3, or positive 5 minus 3 is 2. The other answer is negative 5 minus 3, which is negative 8. We could have done so with factoring. We could do so and check our work. But we want to get used to this procedure. This is how we solve by completing the square. We're going to need it for vertex form, for deriving the quadratic formula, which we'll talk about next week. You'll need it in Algebra 2 when you study ellipses. There is an alternate way I want to suggest that you do. Maybe I'll demonstrate that in one of the problems. Instead of moving 16 like so and adding 9 on both sides, they're thinking, okay, if I am already at negative 16, what do I need to do to make it look like 9? Because that's the perfect square that I want. You'd have to add 25 to both sides, like so. And then you have the rest of the work being the same. Another way to do like these first 2 steps. I think your Algebra 2 textbook may look like this. Just realize it's the same process. What more do I have to add on to make it into a perfect square? Example 4, this is the most time-consuming part. When your a value here is not 1, it gets really annoying. But we are going to talk through those processes after 4 or so examples of completing the square where a is equal to 1. Okay, completing the square, that b over 2 squared idea only works when your a value is 1, like so. Okay, that's not you. That's from the, so that is what I'd all talked about during block 7. We're going to redo all of that. So in this first example, we have x squared minus 6x plus 8. We're going to take away 8 from both sides, following what the book did. Okay, that equals negative 8. We'll identify our b term. In this case, it is negative 8. You'll notice me writing each of these steps out so that your notes make sense. B over 2 is negative 4. B over 2 squared is negative 4 squared, which gets you 16. That's what we need to add on to this equation. You'll see me underline them a lot and drawing some stars by it, because that's a reminder that this is the new step. Oh yeah, you're right. Negative, yes. Thank you. I made a mistake. I wrote too fast. It should be 9. Good catch, Raymond. 9. Thank you, thank you. Like so. Okay. Should be 9. I messed up. I wrote my v-value wrong. So from here, you can factor this. Maybe you're wondering what term goes here. This is why I wrote out b over 2, because you're going to end up needing it. -3. So you can write plus -3, that's fine. Squared equals 1. Take the square root of both sides. So adding a negative just looks like that, same thing. Square root of 1. You're left with x minus 3 equals plus or minus, what's the square root of 1? Just 1. And then you add 3 to both sides. And your two answers are positive -1 plus 3. I think I developed this little branching in middle school because it reminds me that there are two answers. One's +1 plus 3, one's -1 plus 3. And there we go. Okay. All this stuff that happened over here is what explains this 9. Work through a couple more examples. Maybe one more time, demonstrating what the book did. -5 first, that's their first step. Okay. B here is -6, b over 2 is -3, which came from -6 over 2. b over 2 squared is -3 squared, which is 9. We add that to complete our square, extra 9. Don't forget to add it onto both sides, very common mistake. Simplify this. -5, 9, 4. I'm going to be kind of lazy. I'm going to square root this like so. X minus 3 equals plus or minus 2. Add 3 to both sides, add 3 to both sides. So x is equal to plus or minus 2, like that. +2 plus 3 is 5. -2 plus 3 is 1. Ta-da. For 3c, maybe I'll demonstrate that other way of representing it. So here, we'll start by identifying our b value. b is equal to 4, so b over 2 equals 4 over 2, which gives us 2. b over 2 squared is 2 squared, which is 4. So I want my perfect square to look like this. Okay, maybe I'll move that down a bit. Okay, I want it to look like this. However, I'm already at -9. So there's something extra I have to add on to both sides that gets it to +4. So then we see that this thing has to be 13. Okay, that's the other way of doing it. And then you can factor m plus 2 squared equals 13. Square root both sides. M plus 2 equals plus or minus the square root of 13. Subtract 2 from both sides. M equals -2 plus or minus square root 13. And we'll just stop there. Here's the alternative way to complete the square. So more of it happens in your head. Yeah. Depends how you like to think, right? The other one, it's step by step. This same idea, it's like you condense the first 3 steps into one over here, right? That's still the first thing. Depends how you think about it. So we can demonstrate this alternate way one more time down here. start with your b over 2 squared, right? If anything, when you think complete the square, remember b over 2 squared. That's the stuff that you need to add on. The second most important thing is it only works when a is 1, as you'll see in these next couple of examples. When a is 1 is not 1, you have to divide it out, and then it becomes all ugly. Okay, b here is -6. We've dealt with -6 before. Okay, b over 2 is -3, so when we square it, that gives us +9. We want our perfect square to look like so. However, we are already at +7, so we have to tack on an extra 2, like so. As we factor, -3. Where did 3 come from? Remember, this term is right here, b over 2 equals 2. Take the square root of both sides. X minus 3 equals plus or minus square root of 2. Add 3 to both sides. We get our final answer of x, 3 plus or minus root 2. Notice your bookwork, it says leave it in radical form. That means leave it like this. You don't have to turn it into a decimal. It's harder for me to check over your work if you turn it into a decimal. Leaving it in square root form or radical form, I can see if any mistakes happened, where they occurred. All right. So notice in these 4 examples that I worked through, a was all equal to 1. Okay, there's nothing out here. Here. That's why they have this next example in number 4 from page 114. Okay, when a is not 1, okay, we can't apply that perfect square idea because the picture that we drew over here, right, notice there's just one x tile. That really matters. So in order to make it a 1x tile, notice their first step is dividing everything by 2. Okay, to make a equal to 1. And now our b value is the fraction, -9/2. And from there, we can continue the procedure I just demonstrated 4 times. Because our b value over here, right, b is equal to -9/2. That's what we cut in half. b over 2 equals -9 divided by 2. You can think about that like multiplying it by 1/2. Since we're already in fraction territory, why not keep it there? We get -4. So then 9/4, I mean. 9/4 squared gets you that 36/25. Oh wait, sorry, I'm thinking about totally different problems. 81/36. Jeez. Okay, that's where it came from. Why was 81/16 added to both sides? That's what was needed to complete the square. And especially in this fraction case, this factor, remember, is just b over 2. Just b over 2. And then you go through those same process, right? Square root both sides, undo whatever operation is here to get your final answer. Okay, 3 more problems. Stick with me a little bit longer as we deal with this case. That first step makes it so much more arithmetic. All right, so you can see, like from block 7, here's the first example with a over 2, right? Oh gosh. So we'll work through that step by step. Okay, here's the first one. You don't like it when a is not equal to 1. So first step, divide everything out by that a value. We get this equation, m squared plus 7/2 m plus 3/2 equals 0. We'll follow through the book's method for these first couple ones. minus 3 over 2 minus 3 over 2. I think it's harder to do like the alternative way with fractions, but maybe I'll be wrong. M squared plus 7 halves m plus something equals 3 over 2 plus something. Let's go through figuring out what's missing in order to make this a perfect square. Dividing by 2 is the same thing as multiplying by 1/2. 7 over 4. Squared is 49 over 16. That's what we add in. Great. M plus, we look here for a b over 2 term, that's 7 over 4 squared equals this stuff. Okay, so I have negative 24 plus 49 on my numerator by making common denominators of 16. Looks like that. So now that's the 25 over 16. As I square root this stuff, to undo the square, I have to take the square root of 25 over 16. You know the square root of 25, you know the square root of 16, 5 over 4. Place them together. 5 over 4. Don't forget your plus and minus. Take away 7/4, take away 7/4. We get m is equal to plus or minus 5/4 minus 7/4. So here we can branch off. We can do this arithmetic. 5/4, take away 7/4, negative 2 over 4, negative 1/2. So first answer, negative 5 over 4 minus 7 over 4. Also something convenient, negative 12 over 4, which equals negative 3. Right? Notice when a is not equal to 1, it becomes such a pain. More fraction arithmetic. So far, so good. And it's very procedural. That part is at least nice, but there's all these moving parts and steps. This one being the key one, right? If you remember that, then you'll be in a good spot. Where did you get the 8s? Ah, over there. So for me, the 8s was me making a common denominator. So I saw a 16, and I was already at 2. So I multiplied it 8. Gosh. Okay, that's a negative. Okay, this is the negative, so maybe I can clean this up a bit. That's the negative 3, and I'm multiplying by the fraction 8 over 8. Does that help? Yeah, I'm doing fraction addition. Adding negative 3 halves to 49 over 16. All right, 2 more examples. This stuff will also be posted. You may just want to focus on listening to this part. That was a skill I think I developed later on in college. In high school, I would like frantically try to copy, but not really listen. And then later on, when I looked at my notes, like, oh, none of this makes sense. So then now when people lecture at me, I just listen. And then hope that they'll be posted afterwards, or make a friend that takes really good notes. All right. First step, since a is not equal to 1, we have to divide it out. R squared plus 1/2 r minus 3 over 2 equals 0. We move this term over. So now we have r squared plus 1/2 r plus something equals 3 over 2 plus something. I draw the blanks to remind me it has to go onto both sides, and also this is what it means to complete the square. I'm adding in something to make it look like, oops. Is there a question? B over 2 squared, 1/4 times 1/4, 1/16. So r here plus 1/4, where did the 1/4 come from? That's your b over 2, equals, again, some more fraction arithmetic, 3 halves plus 1/16 times 8 times 8. Okay, that big 1, 24 over 16, 1 over 16, oh nice, 25 over 16 pops out again. We can take the square root of both sides. R plus 1/4 equals 5 over 4. Don't forget your plus minus. Subtract 1/4. R is equal to positive negative 5 over 4 minus 1/4. Our two answers are positive 5 minus 4. Oh nice, 4 over 4, that's 1. Negative 5 over 4 minus 1/4 equals negative 6 over 4. Negative 3 halves. So far so good? Yes? Gary, any questions? No? All right, third and last example of completing the square. Maybe we'll try the alternative way and flex our brain muscles in that regards. I don't know if it's going to be easier. Let's find out. Divide by 3, divide by 3, divide by 3. X squared plus 7, oops, let's write it like this, plus 7 over 3x minus 2 plus something equals 0 plus something. As we do our b arithmetic, b over 2 is 7 over 3 times 1/2, 7 6. Yeah, that's not as nice, right? Because then you got to mental math more fractions. But maybe that works for you. 7 over 6 times 7 over 6, 49 over 36. Right, so we want to get to 49 over 36, but we're at negative 2, which looks like negative 72 over 36. So either way, we have to figure out what the difference is. Correct? So if we're at negative 72, we want to get to positive 49. We gotta add in something positive. Make this line go away. Okay, go backwards by 3. And then, wait, shoot. Okay, so the alternative way has me confused now. So I want to get to 49 over 36. I'm already at this one. So then I have to figure out the difference. That's 323. Is that right? 23 over 36? How's that? Yeah, it's much worse, right? we'll try it at least. It doesn't seem right though. I'm staring at it. Positive this one. Oh yeah, you're right. You're right, Alex. Thanks. So yeah, you're right. It's positive. Should be positive. So 72 over 36 plus that 49, because we're negative, gets us to 121 over 36. Yeah, that sounds familiar. 121. Gary, what's happening? Okay, so from there, yeah, Alex, you're right. Like either way, you would have to do this arithmetic, which we were able to avoid in the previous problems because the numbers were all whole numbers, right? But in this case, I like the what the book was doing because step by step it makes it less error prone. I don't think we can avoid it. Okay. This thing, we know what it should be. It's over here, 7 over 6 squared. Oops. equals 121 over 36. Take the square root of both sides. I'll write out the steps this time. Oop. Square root plus or minus 121 over 36. 7, that equals plus or minus 11 over 6. Minus 7, 6, minus 7, 6. X is equal to plus or minus 11, 6, minus 7, 6. So let's start branching. 11 over 6 minus 7 over 6 gives us 4 over 6, 2/3. Negative 11 over 6 minus 7, 6. Negative 18 over 6, negative 3. Ta-dang. Cool. So it seems like when a is not equal to 1, this alternative method, it's up to you whether or not you like it better. Those are your 3 problems demonstrating how to complete the square. We build on this to go over vertex form, to derive the quadratic formula, and you'll see it later on in Algebra 2 when you talk about parabolas again, ellipses, equations of circles, and yeah, that's all.